Here in example 1, we want to find the derivative for the given function. So I always want to rewrite problems with powers of x, because then I can connect it to this rule here when finding a derivative. It's a very common derivative that comes up in calculus. So I see the first term in number 1 already has x to some power. So that's very easy to connect there. However, I can rewrite square root of x to be x to the 1/2 power. And then this term will become minus 1/2 x to the -3. So you want to get in the habit when you're taking the derivative of first rewriting your function with powers of x whenever possible. So now I'm going to take the derivative. And notice I wrote this this notation here for f prime of x to show that now I'm taking the derivative. You must make this statement once you're starting the derivative. So in order to take the derivative of a constant times x squared, I'm just going to do 4 multiplied by 2, that's bringing down the power of x, and then 2 minus 1 power. Here, this will be plus 1/2 times x to the 1/2 minus 1 power. And then this will be subtracting 1/2 multiplied by -3x to the -3 minus 1 power. So a lot of times you can do this step in your head, but I'm just showing you this so you can see how I am connecting it to this rule here. So I take the exponent down in front, and then I do the exponent subtracting 1. So now I need to simplify. F prime of x equals, well, 2 times 4 is 8, and this will be x to the first power, and this will be plus 1/2. Now 1/2 minus 1 is -1/2, which means I have the square root of x in my denominator. And then here, this becomes plus 3/2. -3 minus 1 is x to the -4, which means x to the 4th power. So normally we do not rationalize functions here. That's a simplified enough answer. Let's try the next example.